Hello and welcome to today's video. This is now the final version of the power controller for my quad output power supply. And it might look a little different because we took out all of the optocouplers that were giving me issues. Well, it wasn't the optocouplers that were giving me the issues. My microcontroller can only sync and source 10 milliamps per pin, and we really needed about 20 milliamps to turn these guys on hard enough to get the relay to click in. If you watched the previous couple videos, I demonstrated that. So these guys were out, and then you might also notice, hey, you didn't use these MOSFETs. You said you were going to use those. Well, these things are so overkill. The fact that I have 4 of them, I probably bought them to build an H-bridge and a little DC motor controller at some point. So I want to keep them around. I don't want to use them up. These guys are rated much overkill than what I needed. So I ended up with these little tiny surface mount MOSFETs here, and I can show you what's going on there. So the MOSFET I was going to use is this big ST part here, and they're 75 volts at 80 amps. And the one that I ended up replacing it with is the IRL L014N MOSFET, and it's rated at 55 volts, 2 amps, and most importantly, if we scroll down, and 2 amps is definitely more than enough to turn on the relay. If we scroll down to here, our gate threshold right here, VGS, is 1 to 2 volts, which is good because my microcontroller can only put out 3.3 volts on an I/O line. So we're guaranteed to fully saturate and get that guy fully on, so we don't have to worry about that. And this guy's VGS was, I think it was around, yeah, it was, his gate threshold is, typical is 3 volts, which is really cutting it close. 2 volts would be awesome. It would work if it was 2. With my luck, it was probably 4 volts, and we wouldn't have been able to turn them on anyway with the micro. So, just hedge my bets. The problem is that these guys are surface mount, and so this is really a through-hole design, and I had to solder, I don't know how close I can get this before it goes out of focus, but I essentially soldered wire wrap leads to the pins of the MOSFET so that I could turn them into through-hole parts. Yeah, it's a little messy. It's not as clean. You could see I've got solder in all the pads where I pulled out the opto isolators, and even if I did go with these guys, it would have been a pretty tight fit in there, but I think they would have fit, but these guys worked out really well. So you probably want to see the schematic for that, so let me grab my little handy cheat sheet here. Back of the envelope calculations. So this is, let's see, the original circuit, yeah, it was this one, except we only had one 100 ohm resistor, and the problem was we could only get 10 milliamps out of the micro pin, so we couldn't actually turn this guy on hard enough to, source enough current to turn on the relay. In this design, because we're using an N-channel MOSFET, I had to connect the relay up to 21 volts, so it's always at a 21 volt potential, and I don't like that, but it's inside. Nobody's going to touch it. I mean, if this is like really high voltage, then it's a danger, but 21's low enough. It won't kill you or hurt you. So anyways, it got a 100 ohm resistor, and that just limits. This is a capacitor, so we don't want to, when this is off, it's discharged, and if you turn your micro pin on, all of a sudden it's got to charge up a capacitor, and you get a lot of current flowing through there. You could blow out your pin. So this 100 ohm resistor is literally just a current limit for my microcontroller, so it doesn't damage the pin on the micro. And then this 10K resistor just keeps the gate off, so that when the micro is in its bootloader or hasn't booted up yet and set the I/O state, these come up as inputs, and sometimes these guys can float to where they start turning on or partially on, and that could damage it because it's only rated at 2 amps, and its safe operating range would be really small at that kind of current. So we want to make sure we hard switch it on, and that's what this does. So yeah, I think that's pretty much it for this video. Gonna go ahead and plug this guy in, and hopefully it works. but it is kind of messy. But yeah, it's point to point. That's typically what they look like. And I've also got a few things you're not supposed to do, like I have bare wires crossing bare wires with an air gap, but oh well. I didn't want to put... These are too small a distances to cut wires for. I could have put some heat shrink on there, but it'll be fine. It's okay. Oh, and yeah, it does actually have a USB port on it, and this gets mounted in there this way. So if I do need to use the USB port, I can cut a hole in the side of the case and have that accessible for, say I want it to be USB controlled. It could be USB controlled. Who knows? Future applications. Yeah, limitless. You can do whatever you want. Anyways, yeah, I'll go ahead and put it in, and see you in the next video. Thanks for watching. Bye.